Hello everyone, welcome to IT Twist. My name is Gaurav. In this video we will learn about object-oriented programming in Python. Please note that this is a very important topic of our hands-on Python course. So I would recommend you to please make a handwritten notes for this as well. Also, if you are new to object-oriented paradigm, then please practice the content of this video. If you are not subscribed to this channel, please make sure to hit the subscribe button for getting information on latest technologies and programming tutorials. Let's understand what is the use of object-oriented paradigm. Earlier, we have seen a procedural programming paradigm in our course in which we have a function that operates on a data. In real-world applications, we have tons of functions. If you follow procedural programming paradigm, if you make a change to one function, chances of other functions breaking is very high. This is what we call spaghetti code, as there is too much interdependencies between the function that changing one function will result in affecting the other. In order to solve this problem, object-oriented paradigm came into picture. Object-oriented programming make our job as a programmer really simpler, and in the object-oriented world, we group a data and functions into a unit called object, where the data is called properties and functions are called methods. Now let's make our basics of object-oriented programming really clear by comparing the both approaches in Visual Studio Code. So let's get started. Consider an example of calculating average grade of a student. So in the traditional approach, we will create two variables, student underscore 1. Here we will just define some key value pairs like first underscore name as, let's give it Adam, last underscore name Potter, and let's give marks as well in the key, and this will contain list, and in list we will give some marks out of 100 of 5 subjects, say 80, 90, 70, 60 and 50. So similarly we will create another variable of student underscore 2, and this will hold the information of second student. So let's give first name as Harry, let's give Johns, and now we will give marks as 60, 95, 73, 62 and 45. So now we need to calculate the average grade of these two students. So how will you do that? You will create one function which will be, say, calculate average grade, and this will accept a list of marks, and we will return the sum of marks divided by length of marks. So when I will go ahead and print this calculate average grade of, say, student 1 dot get, and let's specify the key of marks, and similarly we will calculate the average grade of student 2. And when I will go ahead and run this Python oops basics.py, you will see 70.0 and 67.0. So this calculate average grade method doesn't know that it is calculating the average marks of student 1 or student 2. So if we go ahead and print this calculate average grade of some random list, say 1, 2, 3 and 4, so when I will go ahead and run python oops basics.py, it will still display 2.5. So as I said earlier, this calculate average grade has no relationship whether it is displaying the average grade of student 1 or student 2. So now let's see the object-oriented approach. So I'm just cutting this particular line and I'm just pasting down in this particular comments, and let's go ahead and just see the object-oriented approach. In the object-oriented approach, we will start by creating a class. So how to create a class in Python? So we used to create classes by using this class keyword and then providing a class name. So let's give it a student as of now. If we want to define an empty class, we will simply write this pass keyword and we are good to go. So what is mean by this class? So let's understand this. In real world, you will often find many individual objects, all of the same kind. There may be thousands of other students in the existence. Each student was built from the same set of blueprints and therefore contains the same components. A class is a blueprint from which then individual objects are created, and we used to define an object by using this, let's say student underscore 1, which will be equal to the student, and we will just give a parenthesis over here. In classes, we have a special method which is known as underscore underscore init underscore underscore. So this particular method is also known as initialization method or constructor. So which accept one variable which is self, and here let's write pass as of now. And when we are creating an object, this particular methods fire every time. So we have created an object over here. So let's write a print statement here that object is created. Object is created. So when I will go ahead and run Python oopsbasics.py, you will see object is created. So let's create another object, student underscore 2, and when we will create another object, you will see this object is created 2 times. As every time this initialization method or constructor is fired when we are creating this object. As I told you in starting of this video that an object contains a data which is also known as properties and functions which is also known as methods. So let's create some properties and methods inside this class student. So first of all, a question is coming in your mind is why we use this self. So the self parameter is a reference to the current instance of the class. So it is referring to a particular object. So when we are calling this student underscore 1, then this self is referring to student underscore 1. So when we are creating this object student underscore 2, this self is corresponding to this student underscore 2. So let's create some properties. So in order to create properties, we always refer to this self variable. So we will say self dot first underscore name, let's name it Harry, and self dot last underscore name, let's name it Jones, and also give some marks as well. So we will give some marks. So let's refer to this marks as of now. So this will be a list. So these are the properties that we have defined inside our blueprint, which is class student. So we can access this particular properties which we have defined here. So when I will write print student underscore 1 dot first underscore name and print student underscore 2 dot first underscore name. So let's print this and see what it returns. So when I will run this, it will say Harry and Harry, because first we have created an object student underscore 1. So this constructor get fired, and then these particular properties are defined, which is hard coded as of now to a values. So these values will get initialized. So when I will refer student underscore 1 dot first underscore name, it will return Harry, and then I'm again creating one object which is student underscore 2. It again created some properties, first underscore name, last underscore name, and marks, which is also a hard coded values only. and it returned me again Harry. Now let's consider our previous example where we have student underscore 1 and student underscore 2 with the respective information of first name, last name and marks. How to achieve that in class student? So we can utilize this constructor. So we can pass some parameters over here and we can pass some arguments that we used to pass in the functions. Like that way only we can add some parameters over here in the constructor. This is also called parameterized constructor. So let's add the particular parameters inside this initialization method. So we will add first underscore name, last underscore name and marks, and for the student underscore 1 we will copy the information from here. So we will say Adam as a first name and last name as a Porter. So here we will pass Porter as last name, and then we have marks which is of list type and we will pass it over here. And for the second student we will pass the first name as Harry Jones as a last name, and then in marks we will pass this particular list. So instead of referring to this hard-coded values, we will refer to this parameters. So self.firstname will be is equal to first name, and we can anyways refer to any other name as well, like first name here and first name here. It will also work. It is not necessary that the property name and the parameter name has to be same. In this case I have maintained it same, but you can keep it different as well, so don't get confused. So self.marks is equal to marks. And when I will run python oopsbasics.py, you will see Adam and Harry now. So to add on this, we will add another property which is full name. So how to make a full name? So it is really simple. We will say self.first name and we will just concatenate with self.last name. So instead of first name, now I am referring to this full name. And when I will run this python oopsbasics.py, it will say Adam Porter and Harry Jones. So once again, let's understand the concept behind this particular thing. So first of all, we have created student underscore 1 object. So this particular initialization method or constructor get invoked. And this time we are passing some parameters. So this self is corresponding to this student underscore 1. So we are passing first underscore name as Adam, last underscore name as Porter, and marks as a list. So this particular student underscore 1, which is corresponding to this self, so self dot first name will be equivalent to this Adam, and self dot last name will be equivalent to Porter, and self dot marks will be equivalent to this particular list. And after that we are creating one another property full underscore name, which is equivalent to self dot first name, which is equivalent to Adam, and self dot last name, which is equivalent to Porter. So if we print student underscore 1 dot full name, it will show Adam Porter. And after that we are again creating student underscore 2 object, and again this methodology, this first name will be corresponding to Harry, last name will be Jones, and this marks will be this list, and we are creating this particular properties, and this time the self is referring to student underscore 2. So when we wrote student underscore 2 dot full name, it returned Harry Jones. In our previous example, we have created one particular function which returned this particular average grade. So let's utilize the same in the classes. So in classes we can also add our functions. So we can add it like this. So this calculate average grade, and this time it will not take marks as an argument, it will take self as an argument, and after that we will refer to this marks by using self.marks, and so self.marks and length is self.marks. In order to calculate the average grade, we can simply say print our class name, which is student dot calculate average grade, and this time we will pass student 1 in argument. So this self will be equivalent to student underscore 1. So sum of student 1 dot marks will be equivalent to this particular list, and the length of this student 1 dot marks will be equivalent to the length of this particular list. And the same thing we will apply here. This time we will pass student underscore 2. So when I will run Python oopsbasics.py, you will say Adam Porter and its grade and Harry Jones its grade. So there is another way to access the methods inside our object. So we will write student underscore 1 dot calculate average grade. So here also we can say student underscore 2 dot calculate average grade. So when I will run Python oopsbasics.py, you will see Adam Porter 70.0, Harry Jones and its particular calculate average grade. So this time, this particular calculate average grade knows that this particular grade is corresponding to this student 1 and this average grade is corresponding to student underscore 2. That's all for the basics of object-oriented programming. In the next video, we will dive in more depth. If you have any questions or suggestions, please comment in the comment section below. See you in the next video. Thanks a lot. Thanks for watching.